Hi, hello, and welcome to BK's Tech Stack. I am BK. Today, we are going to learn about core philosophy of multi-agent systems.
Let's start with the basics. A multi-agent system uses an LLM to manage an application's flow by orchestrating multiple specialized agents. Instead of trying to build one giant model to do everything, we break complex problems into smaller tasks. Each agent then handles a specific domain, making the entire application easier to develop, test, and maintain.
Think of a network architecture as an open team where any agent can talk to any other agent. There is no boss directing the flow. It is perfect for tasks that do not need a rigid, predefined sequence. Here, you see how we initialize a state graph and add nodes for a researcher and a chart generator. When using LangGraph, building a workflow follows a consistent path. First, you define your state graph to hold your conversation history. Next, you add your nodes, which represent your agents. Then you define the edges, or transitions between them. And finally, you compile the graph into a runnable object.
Here is the code to bring that workflow to life. We initialize the builder, add our specialized nodes, the travel advisor and the human input node, and define the starting point. Crucially, we add a memory saver, which allows the application to save its state, so conversations can be resumed later.
Moving to CrewAI, this framework is specifically designed for orchestrating autonomous role-playing agents. It is like managing a real company department. You give the crew a goal, and it manages the collaboration patterns and task execution required to reach that goal effectively. To use CrewAI, you need to understand two sets of things. First, the components of a crew: the agents, their tasks, the process type, and the manager. Second, the attributes of an individual agent: their specific role, their core goal, their backstory for context, and the tools they are allowed to use.
Creating an agent is straightforward. You assign them a role, a specific objective, and a backstory to set the tone. You also give them a list of tools, like a search tool that they can use. Setting verbose to true is a great practice, as it lets you see the agent's internal thoughts in the console.
Once you have your agent, you define the work they need to do using the task class. A task needs a clear description, a specific expectation for the output, like a list of bullet points, and the reference to the agent responsible for it. This keeps your project scope tightly managed.
How your agents work together depends on the process type. Sequential is the simplest, where tasks follow a line. Hierarchical is best for complex projects, as it uses a manager to delegate. Consensual is about collaborative decision-making, where agents communicate to decide the best path forward.
Finally, we instantiate the crew. We pass in our list of agents, our tasks, and define the process. The kickoff method then triggers the whole operation. It is clean, declarative, and highly scalable for enterprise workflows, where you might have dozens of agents working in tandem.
Before you start, make sure your environment is ready. I recommend using Uve to install CrewAI and manage dependencies. It is fast and keeps your project clean. Simply run the install command and you are ready to start coding your first multi-agent system.
One of the most important concepts in multi-agent workflows is the handoff. This is how one agent passes control and information to another. It is essential for modularity. For example, if a travel agent hits a question about hotels, they can simply hand off that part of the conversation to a specialized hotel agent. To implement handoffs, we can create a tool dynamically. This code shows a function that creates a handoff tool. When the agent invokes this, it triggers a switch to the named target agent. It is a very clean way to make your systems adaptive and dynamic based on user needs. Finally, let us look at the command object. It is a powerful LangGraph feature. It allows an agent to do two things at once: update the current graph state and explicitly go to the next node. It gives you total control over the direction of the conversation.
Congratulations! You just learned presentation topic with both the theory and the hands-on implementation. Now put this into your project, share your result in the comments, and let me know how you would adapt it for a SaaS or enterprise workflow. If you found this useful, like, subscribe, and share with someone building real applications. Next video, we will build a deeper production-ready extension of this pattern.